Hi.
Hello, this is Aaron Wiesner of Local Future. I'm here with Christina Snyder. Christina is an architect, licensed residential builder, and Passive House Institute accredited building certifier. She's doing her certification work as an independent contractor under the auspices of the Certifiers Cooperative, and she serves clients in both the USA and Canada. Christina, how are you doing today?
I'm doing well, thank you.
So my goal here is kind of to talk to you as if I'm an alien from outer space and I don't know
Okay.
anything at all about Passive House, what it is. And so if you could keep your answers as short as possible,
Yes.
I'll ask lots and lots of questions within our like 20 or 30 minutes. So first of all, what is a passive house? In the
Okay.
short.
Yes. So a passive house is a building that uses no more than 15 kilowatts of energy per square foot for the heating and cooling loads in a year's time. So that works out to about 1 watt per square foot, or about the amount of energy it takes to run a hair blow dryer. You could heat these buildings with a hair blow dryer.
Okay, so what
The
I'm
furnace.
hearing is that this is a standard for building buildings, which could be houses or um,
Yes.
businesses,
Commercial, residential, whatever.
and the goal is basically that these structures use a very small amount of energy. Is that like
Yes.
50% less energy than the typical home, or what? How much
It
less
can be as
energy is it?
much as like 80% less energy than. It depends on the country that it's in, but the U.S. is a little bit behind raising their codes, so uh, it's on the order of like 70%, I think, in the U.S.
Okay.
less energy.
So my house was built in 1997, I think, and it's
Uh-huh.
just a regular house, about 1,000 square feet on the main level, and then the finished basement level. It has a furnace, it has a water heater, it has just the regular stuff. So
Right.
how would, suppose I was to build a house more or less identical as far as the layout and everything, or if I was to try to make my house into a passive house. So what would be the difference as far as the house itself? I mean, what's different? I mean, if I was to like say, I want
Yes.
the exact same looking house, I want it to look the same,
Mm-hmm.
but I want another one right next door, okay,
Yes.
on the empty vacant lot. So what is the
Mm-hmm.
difference between my house and this passive house?
In most cases, the walls are going to be substantially thicker. The windows may be triple pane instead of double pane. One thing that all passive houses have in common is that they are using a heat recovery or energy recovery ventilator, so that even though they're building these houses as tight as if they were a balloon, they still have plenty of fresh air being brought in from outside, and they're taking out all the stale air without losing most of the heat that's involved. So they recover most of the heat that was in that air before they send it away.
So this is something that maybe a lot of people haven't heard of, a heat recovery ventilator. Is that
Yes.
like the price of a furnace? Is that like $5,000, or is this like I mean, is this in the attic? Where would it be in the house even?
Um, you, it needs to be near the outside walls usually, because you have to have, the longer the duct runs are between the equipment and the outside walls or outside of the building, the more energy gets lost. But it can be in the attic, it could be in the basement. In order to meet the the PHI passive house standard, you usually need to use a PHI certified heat recovery ventilator, which it's confusing when you compare those to the ones that are sold here in the US, because there's a different testing protocol involved.
And
And
so how much would the US ones run? I mean, is that like a $3,000 item, or what is that?
Probably a couple $1,000s, and the European ones are more expensive, maybe half again as much.
Okay,
But
so what you've
the
said is,
difference would be is, you know, you won't need a furnace in a passive house. So the money that would normally go into a furnace can go towards the ventilation system. And passive houses are probably the only buildings that are basically the best possible spaces for public health, because they're ventilating with 100% fresh air and not recirculating.
okay, so I have a question right away then. So I'm in Michigan. You're in Michigan right now.
Yes.
It's nice 50 Fahrenheit today, but a couple days ago it was like 25 or 20
Yes.
Fahrenheit at night. So negative
Right.
5C. So how is it the house is warm then, a passive house, if it doesn't have a furnace?
Well, the energy comes from three sources. By doing all of the energy efficiency measures, we can get the amount of heat loss low enough that the heat can then be supplied from three sources. About a third of the energy is coming from the solar energy that's coming through the windows. Another third of the energy is coming from the people and the appliances that they're using, and then including lights and stuff like that. The last quantity is the amount of energy that you need to make up. Typically, it's being drawn from the utility grid, or you might be supplying it with renewable energy like photovoltaics or wind. So you can get to net zero. Passive house is probably the best way to get to net zero, because you get the energy consumption so low that you don't need as large of a renewable energy system to supply it.
So it sounds like if I was to build this identical house right next to mine,
Mm-hmm.
the walls would be thicker, the windows would be triple paned, there'd probably be more windows on the south sun-facing side. And then does there need to be a special sort of where the south side windows are? Does there need to be some special sort of mass to be warmed up, like some bricks or something inside, or is this not really necessary?
No, as long as the sun's coming through the windows, that energy is pretty much being held. I am using a radiant floor system in my own project, and for that, we probably will use a darker color on the floor itself, but it's not absolutely necessary to do that. In some cases, lighter colors are nice, because then they help to bounce the light farther in and get more of the surfaces involved in storing the energy. So I think the other thing I would say is that the quantity of windows on the south is not a huge amount more than a regular house. In fact, one of the mistakes that people tend to make more often than not is that they put too many windows on the south side, and you can actually create overheating problems for yourself in the middle of winter. There have been times when I've needed to open the windows in the wintertime because it's just getting a bit too warm.
So you said about a third of the heating comes through the windows. Another third comes just from the stuff in the house, the people and the electric devices. So I guess you're talking about like the refrigerator, and maybe the oven when you use the oven, and just things that seem to be on, like the heat recovery ventilator. Does that? Oh, a computer, sure, yeah. Computers. My computer gets warm too, and then so to make up for that last third. So is that like maybe electric radiant heat, baseboard heat in a couple of the rooms or something?
You can do any number of different ways to supply the heat, and it depends on what you intend for your source to be. The Passive House Institute doesn't mandate how you meet the goals; it just sets limits. And those limits are basically the same the world over. So I am choosing to do radiant floor heat because we hope to eventually be able to take our house off grid and be able to meet the heating loads with solar thermal energy instead of solar electric energy.
So if we were to look at a Venn diagram, then if you have passive house here and off grid over here, then you could have a passive house that's off grid, but there are off grid houses that are not passive house.
True.
There's also passive houses that are not off the grid.
Exactly.
So these are two kind of different things then.
Yep.
But they can overlap.
They can overlap. Same thing with net zero.
So now for a passive house, what would be, if I was to go to a builder and I was to say, hey, I want this built up to passive house standards, which means you're going to need to install these triple pane windows and you're going to need to make the walls twice as thick or 3 times as thick, whatever, and you're going to not put in a furnace, but what other changes would I need to tell them about how they be building the house? I mean, do they need to put in different drywall, or do they need to insulate the foundation different, or what sorts of things?
Air tightness is a big part of it. Also, typically you usually have some insulation underneath. If not the foundations, at least the floor slab. Some jurisdictions have earthquake requirements and you can't put the insulation underneath the foundations themselves, but usually you at least need to have it under the floor slab.
So when thinking about building a house, you have the footers, so you can't put insulation under the footers, and then you've got the walls, the poured walls usually on top of the footers, but when you pour the basement, you could put insulation down first, like a foam or something, or?
Some passive houses outside of those earthquake zones will even have like a raft of foam that goes completely across the bottom and up the sides of the foundation, and the whole building is basically floating on top of the foam, on top of the ground. So
now, if I was to like have a house, if I was to go to a builder and say, hey, I want to build a house identical to mine, you know, and he says, oh, okay, I can do that for about 150,000 US. And then I said, yeah, but I want it built to these passive house standards. So what would he come back with and say, well, your walls are going to be thicker, your windows are going to be thicker, you're not going to have a furnace, but you are going to have a heat recovery ventilator, and you're going to have foam underneath the floors or whatever. What would he come back for a price if I was to say 150, or let's just say it's 100? Say it's $100,000 because he's my buddy, he's throwing in a lot of the labor or something.
It probably is going to depend on how much experience he's had with doing these projects before. People who've never done it before are going to overprice their labor and stuff like that because they have no idea what's going to be involved. But people that have been in the process of doing passive house are able to do, certainly multifamily is in the range of like 2 to 5% more.
Only 2 to 5%.
Yeah. And for single family, it's a bit higher because there's more surface area to volume ratio.
Okay.
So but it still should probably be under like 10%.
So what I hear you saying is if it was like an apartment building that was built to passive house standards, the increase in the price would be less because really your the outside volume, surface area, the outside surface area is less.
Yes. On the really large passive house multifamily projects, some people are bringing those in at cost neutral.
Really?
With conventional construction. But then the utility bills are a tiny fraction.
So for people that are, you know, rich, so to speak, and they're
Yeah.
going to already spend $500,000 to build a house that's
Yep.
4,000 square feet, 8,000 square feet, then it's going to be more money, obviously, but it's not going to be like 50% more or
Right.
even 25% more or anything like that.
Yeah.
So I understand that right now, today,
Mhm.
you were attending a Passive House conference virtually that's being held, organized in Canada.
Yes.
What sort of things are like the buzz in Passive House right now? I mean, is there new stuff? I mean, what would be new, or is it more just, you know? I'm really curious. What have you learned in your day?
Right. So obviously Canada has some much colder climates than we do. And so that means that they typically have to go for even more state-of-the-art technologies to be able to meet the Passive House standard for that. And the other thing that's important to do when you're trying for a really tough climate like that is to actually, and it's a good practice for all Passive House projects, but you really want to try to undershoot your initial goals for the, there's a level that you have to get below to become a Passive House. So your initial modeling, you want to be quite a bit below, because there can be things that come up in construction that change things for the worst. And you want to make sure that you're not going to get caught out.
So I was watching a video this week. I have a small clubhouse I built, 100 square feet clubhouse I built for my sons. My wife and I built for my sons. And we were looking at insulating inside with foam bats or
Yes.
fiberglass bats. And I watched a few videos about that, and someone came out with a infrared camera, and they were going around and showing
Yes.
how to use that in a house, and how, like in my house, I can imagine, I mean, I know there's some certain cold spots. During the winter, I can touch the wall and the wall is cold. In fact, there's even been ice on one spot in our house, not recently, but a few winters ago. There was like, why is there ice there? So I'm imagining that if you were inside or outside one of these passive houses with that IR camera, that it would basically look like nothing, like it was cold or hot or whatever.
Yes, it does look very cold compared to the adjacent houses from the outside. And you can usually see where any remaining thermal bridges that did not get solved are at, because you can actually see where the heat's coming through a little bit more. Usually the window frames lose more heat than the glass, so those will be a slightly warmer color. The other thing that is done to the infrared pictures aren't a requirement for Passive House certification, but blower door testing is. So that means we actually measure how much air is leaking out of the building, because all of that leaking air represents heat loss. And it also, it's important for 3 different reasons. One is the energy consumption, but even more importantly is health and the durability of the building, health of the occupants.
How does that work, Christina? So do you come to like the front door and you open the front door and then you somehow seal off the front door, and are you blowing air into the house, or are you sucking air out of the house?
You do 5 of each.
Okay.
The Passive House protocols, you do 5 pressurizations to different levels of pressurization, and then 5 depressurizations.
So you're basically trying to inflate the house and then deflate the house.
Yes, yes.
And so you have some sort of an air pressure gauge inside the house?
Exactly, and that gives you like a line of data points that can predict how the house is going to perform in different kinds of atmospheric weather conditions. Can be extrapolated from the blower door pressure testing.
So is this with the heat recovery ventilator on or off, or both?
Well, actually, you're sealing up the heat recovery ventilator openings, because everything that goes through that equipment is going to have the heat recovery exchange applied to it. So it's not really a leak.
Sure.
But all the other openings are supposed to be the way they would be in normal winter operation, which is, doors, the windows should be closed and sealed, and interior doors should be open to allow for the airflow.
Now, suppose I had the builder I hired. He was trying to get to passive house standards. You came out to test it.
Yes.
And you said, I'm sorry, but it didn't quite make it. I mean,
right.
Does that make me sad, or does that make me say, well, at least I know was built pretty well, and the fact that I can't put a
right.
sticker on my window isn't such a big deal, or is it a big deal?
There is a sort of a near miss category of certification for passive house buildings called a low energy building. So if you missed the final blower door test, that would be where you'd end up. But in many cases, you don't wait until the end of the project to do the blower door testing. You do it at certain points all the way through while you still have the air barrier exposed, and you can actually find the leaks and fix it. So you find those leaks in the balloon, you seal them up until you get it tight enough that you're going to pass that final test.
Now, Christina, this is something you've been doing, been interested in passive houses for like 15, 20 years already. What interested you in this? I mean, why do you do this sort of thing with your life?
I started back in 6th grade designing energy efficient structures. Back then we didn't call it passive house, it was just passive solar design. But when I became aware of passive house, which I think was about the time of participating in the solar decathlon project in 2007, and that was the first year that there was a team from Darmstadt that built a passive house in that competition, and they wiped everybody else off the map. So it's kind of a case, if you can't beat them, join them.
So as we wrap up this call, suppose I'm a viewer and I'm in California or Ontario or in Auckland or something. Where do I go next to learn more about passive house? And if I'm trying to either renovate my house towards the passive house standard, or to work on new building, or maybe I'm a building contractor who builds homes, I build spec homes. Where do I learn more about this? Okay,
so that's why I gave you the 2 links to put in the YouTube
video description.
Video description. There's one for the Certifiers Cooperative that I work for. There's also one that takes you to one page of the Passive House Institute's website that's extremely comprehensive. They have, in addition to that page that lists certifiers, accredited certifiers, there's also pages that list accredited consultants that can help you design projects, people who've been through the tradesperson's training, people who do the verification work where they're coming out with blower doors to do testing and such during the construction process. So there's a huge number of resources that you can download there, and a whole lot of really good information. One of the fun things for new people is there's some children's books about how to build a passive house, and there's also a fun video where somebody's like animating, sketching about what is a passive house. So I think there's links to both of those on that website.
Great. And if someone wants to get directly a hold of you, Christina, or learn more about you and what you do, how can they go about doing that?
The Certifiers Cooperative link, there's an an about page that describes us, and there's a contact us link that you can reach us for that. So.
All right. Well, thank you, Christina, so much for being on this call with us today.
Okay.
And if you are viewing and you have any questions or comments, please put those down below. Look at the description below. Please thumbs up if you appreciated Christina giving us her time today.
Yeah.
And thank you so much for spending some
Thank
time
you.
with us,
Thumbs
Christina.
up. Thanks for
And
the interview.
And I hope you have a great day, final day for the conference tomorrow.
Yes. Thank you.
All right. Bye-bye.
And happy holidays when they come. Take care. Bye.